This is the Sloan and Chace lathe now. It's been cleaned up, painted, and I've started to assemble it and check out on the accuracy. So I'll take it a step at a time and film each little bit to show how accurate or inaccurate it is at various points. But so far I'm pretty pleased. It's really almost as good as I thought it was. I have this now mounted between two dead centres here. I've recut in the tailstock for a 1 Morse taper, and I've made a centre to fit the collet holder in the headstock, so that's now secured with the collet closer. In order to move this up and down the bed, it is necessary to clamp the two parts of the carriage together, and it's got no bedway to run up in the same way as it would normally do on a screw thread, so you just have to move this by hand. I loosen the screw underneath and move this to and fro, and you can see the needle's currently at 0. Snagging slightly underneath that. So that's at 0. That just at 1.01. Oh, that's 0.01 at that end when I tighten it up. 0.01 in the middle. 0.01 at this end. So it is accurate to less than 0.01 of a millimetre in terms of alignment of the headstock and the tailstock, which is a bit of a relief. So my machining of the tailstock is obviously straight in this direction, but it may not be quite as straight in the vertical direction, so we'll test that now. And I'm now testing the vertical direction, and the same procedure as before. Just have to release the clamp at the bottom, hold it firmly down on the bed, and over the length of my test bar it's about 0.05 of a millimetre, and it's down at this end, so it means that the tailstock is either pointing downwards slightly, or it's dropped, or the headstock may be slightly up at the front, but it's so little I think I'm just going to leave it now. Most of the machining is being done will be done on this lathe in this position here, where there's precious little movement. And the other thing to bear in mind is all of the machining is being done turning on the slide at the top here and not running up and down the bed. So most turning is over just the length of the from there to there as this moves along. Worth just running through the various errors there might be in the measurement. In the end of the test bar ends are drilled with a centre drill and then bored at the angle of the centre drill, and even with that I've got a very slight discrepancy in run out. And similarly there's a bit in the collet chuck. Although, having said that, that might be coming from the bar. I better just check. And that seems to be about 0.01 in the headstock, which is slightly annoying. and at this end I made that a bit more accurately. There's hardly anything on that. Right, now I can show you the various fittings that I've made. So I'll remove the dial gauge for the moment. Now I'll move the test bar and then we'll look at the headstock. So I'm just removing the centre. And that's the centre that I've made up. I hadn't got a means of cutting the keyway slot accurately. I just did it with a Dremel as carefully as I could. But when it's put in there it seems to fit snugly. And you can hear it clicking in, so it's definitely nicely in. Then I made up a 32 ER Collet chuck. Oh, rather, I bought the Collet chuck and made up a backplate for it, and you can see that there are square threads on there, which is a little bit awkward. So I had to cut square threads on the inside of here to match, and I use as a copy the drill chuck backplate that I'm using on the drill chuck. So if I put the dial gauge on this, see what accuracy we've got here. Now I've switched over to a 10mm ground piece of bar just to give a more accurate representation. So for an ER32 Collet chuck, that's pretty accurate. You can see all over YouTube people have to struggle in getting these things to run true, but the machine part of this is pretty good, and the back plate I made up is a nice snug fit, and the screws obviously pull it up nice and tight onto the register, so I'm happy with that. So I'll switch over this the 3-jaw chuck, which is a Vertex chuck that came new, but I've used the old back plate that had on a very ropey chuck with only one set of outside jaws on it. Wasn't a lot of use. And the problem I had with this is that the jaws of the chuck are not in the centre. So I was faced with a dilemma: do I regrind the jaws of a new chuck, or do I alter the back plate and make it so that I could move it around a little bit? So I decided that altering the back plate was probably the best solution. Not terribly happy with it, but never mind, that's the way I have to cope with these things sometimes. So if I just check the run out on this, so this is the accuracy I've got on here, which is 0.03, yeah, 0.03 of a millimetre, which is good enough for roughing work. The thing I'm working on now is trying to correct an inaccuracy in the small ER20 Collet chuck that I've made. and that fits together nice and slunkily, as you can see, so it should be accurate, but at the moment isn't. So the idea is that I've got the smaller sizes in here rather than putting them in the large ER32 size. And this has been driving me nuts trying to get it accurate, and I'm still quite a long way off. I know that the outside of this is perfect, and I know that the threads are straight, so any inaccuracies, and I've got super accurate collets now, so I know that's not the problem. I paid a lot of money for them, and I suppose the most likely culprit is going to be the nut, I think. I'm going to first of all regrind the inside to make it as accurate as I can. It's hopeless, it's miles out. So that's my next job, is to try and get that accurate. I can do, I'm sure, and I'll come back and visit that later. Right, I've fitted the thread cutting attachment now, and what I've done is that I put a new threaded section in here to replace the old threaded section, which was pretty bashed around, and somebody I think had chopped it off short, so that it wasn't giving anything like the degree of movement that would really be needed. I've also fitted, as I mentioned earlier, I think that I was going to make an arrangement to be able to retract the tool, which I've now done. So that's a simple lever underneath there. It's the same tool post that I have on the other cross slide. And there we are, that way. That degree of retraction will take it away from the work. I'll just switch the motor on. At the moment I'm using a motor from a sewing machine. That gives you an idea of how it works, and then it's moving across the slide here. To move back again, I have to reverse the motor, which is a little bit fiddly. Move the other direction now. And that's set up now in that direction for cutting right hand threads. If I want to cut a left hand thread, I need to put an extra gear in the train to reverse it, which is easy enough to do. So that gear cutting I've done just showed that it was able to do what I wanted. That's my very quick test piece. Probably can't see it there. But that's a thread pitch of 80 threads per inch, which I seem to do. That's what it's set up for, with the gears that I've got that came with it. So I've now got to make a whole lot of extra gears. But anyway, I know it works, I know how it works, and it'll be easy enough to make changes. And really quite a nice simple thing to use. The only snag is the tool goes in directly across the lathe, and there's no way of moving it at an angle, which is ideally what you want to do if you are cutting large threads. But never mind, it is an easy thing to use, and I'm quite happy that that's a useful addition to the lathe. So I've got a little bit more work to do on this lever here, but that's nearly there now, and cover all the gears, which I'll probably do out of very high strength aluminium, I think, because that's reasonably easy to cut and they don't get used a lot. So I just thought you might like to see that, something a little bit different.